This is the whole idea behind Scheme. You write an expression in parentheses, the operator comes first, and Kaappi evaluates it. Plus, applied to 1, 2, 3, 6. And expressions nest. The inner parentheses run first. 1 plus 2 is 3, 3 plus 4 is 7, then 3 times 7, 21. There's no precedence to memorize. The parentheses say exactly what happens. Define gives a value a name. Now answer is 42 anywhere I use it. Times 2, 84. You define a function the same way. Here's square. It takes an x and multiplies it by itself. Square of 8, 64. That function is a value, written with lambda. Defining square was really just shorthand for naming a lambda. Here's the same squaring function with no name at all, applied straight to 9, 81. Let introduces local names. A is 3, B is 4, and inside we take the square root of a squared plus b squared. A 3, 4, 5 triangle, so 5. Choices use if, a condition, a then branch, an else branch. When there are more than 2 cases, cond lists them in order and takes the first that's true. Here that's the second clause. Lists are everywhere in Scheme. A quote makes a literal list. Char takes the first item, CDR takes the rest, and cons adds 1 to the front. Those 3 build and take apart every list you'll ever touch. And because a function is a value, you can hand one to map and apply it across a whole list. Square every number from 1 to 5. 1, 4, 9, 16, 25. That little line is kind of our signature. You'll notice there are no for loops, and you won't miss them. A function that calls itself does the work. Factorial. If n is 0, the answer is 1. Otherwise, n times the factorial of n minus 1. Factorial of 5, 120. Everything we just typed lives in a file just as happily. Same expressions, save them, and run the file with Kaappi. That's the whole language. Expressions, names, functions, lists, and recursion. Everything else in Kaappi is built from these 5 things. Next time, Scheme's numbers, which do something most languages quietly get wrong. Thanks for watching. Subscribe for more Kaappi.